Guys, hope you had a great weekend. Welcome back to school. So, we are going to be picking up right where we left off in our volcanoes notes, and you should be following along in your student copy and filling in the blanks as you go along. We're going to do a quick recap from where we left off last time, and then we'll just get right into the notes. So, we talked last time about this process of subduction, whereby one plate that is heavier and denser, the oceanic crust, subducts or slips down and falls and sinks beneath a heavier piece of more dense continental crust. And we talked about that's one way that magma can form. Now, this is also how volcanoes erupt. So, as that piece slides down, you can see here, as it's sliding down, it's going to heat up, right? As we dig down into the earth, right, there's more pressure. That's going to heat it up. The particles are closer together, they're rubbing on each other. So things that are hotter become less dense, right? Their particles will expand, and that will allow it to rise. If it's less dense, it's going to rise to the top, similar to how oil floats to the top of water. So that less dense magma, we can see, begins to float to the top, float to the top. It's got nowhere to go because there's this big continental crust sitting on top of it. So if we get enough magma pooling there, there's a lot of pressure blowing up, and eventually that's going to break through the surface, okay? So just to give you a little visual of what that might look like, if I put some particles in here, imagine these are magma particles underneath the earth, and add some heat to them, look what happens, right? That pressure builds up, and those molecules are going to break through, right? They explode out because of that high pressure that's building up in there. So, similar things happen with magma and volcanoes here. Now, the parts of a volcano include your magma chamber, right? That is that pool of magma shown here at the bottom. They call it a magma reservoir. I thought it was a good picture, so I decided to use it. So, magma chamber, magma reservoir holds just a pool of liquid rock, magma, that's inside the earth, remember. A sill is formed when some of that magma gets through a crack and then hardens as sort of a flat piece of rock. That's called a sill. A vent is similar to like a vent in your home, like a heating vent, where it allows things to go through, like gases, in this case, magma, along with volcanic gases, release through these vents. So sometimes there's more than one, others just have that one single vent at the top. So those are your vents where the magma is coming through, and you can see the magma in orange here. And then as that magma goes down the side, remember that's when we call it lava because it's flowing, right? The word lava means to flow. So on the outside of the volcano, it is lava. On the inside, it's considered to be magma. Now, the last term here is that parasitic cone or secondary vent. And that is this entire sort of shape here that builds up through these, this shape here, that builds up through the layers of rock that are forming. As this magma comes out and hardens here, that's going to form this parasitic cone. Now, they call it parasitic like a parasite. Like think of a flea that lives on a dog, right? Just kind of like hangs out. Same thing here, right? It's sort of like a smaller cone than this giant regular cone right here. So this is like the host, and this is the parasite that feeds on it. So it's just like a little baby volcano on the main volcano here. So those are the main parts to your volcano. Now, volcanoes come in different forms. There's three main types of forms. We're going to talk about the shield volcano first. So the shield volcano forms from many layers of thick, runny lava. So think of like the maple syrup, maybe like the consistency of maple syrup, very thick. It's very wide, as you can see, so very wide, and not too steep, right? It's kind of a gradual dome shape. And there's craters at the top. So a crater sort of dips down, right? So you've got like a crater at the top there. And there's multiple openings at which it can release magma. So see, this is flank vent, flank just meaning it's off to the side. So you have your central vent here where some of your magma will come out, but it can also come out through this vent over here. So that is your shield volcano. So a real life example would be the one Mauna Kea on Hawaii. And this is a dormant volcano on the big island of Hawaii. And it's very old, approximately 4,000 years ago is the last time it erupted. So pretty dormant, meaning it's not erupting. Anything that is not erupting is called a dormant volcano. So it's just totally still, not doing anything crazy, safe for the most part. And then we have a cinder cone volcano, which gets its name due to the shape of it. Looks like a cinder cone. This is the smallest type of volcano, but also the most common. And it's made from what we call pyroclastic material. So pyro meaning fire, and then the clastic refers to the debris. So it's debris formed from fire. And that could be one of many things, and we'll talk about that on the next slide. Like ash would be one example. And it forms a very large crater at the summit of the volcano. And as you can see, it has very steep sides here. So steep, gradual slope, steep slope. So very steep, steep sides. You don't want to fall off of that volcano. That might be a little bit painful. So let's talk more about these pyroclastic materials. Anything that is thrown into the air during an explosion is considered to be pyroclastic materials. So these can be large blobs of magma. Think of like that magma erupting and then going out into the air in a very explosive type of eruption. Or the lapilli, which are just tiny little pebble-sized rocks. And then you have your volcanic ash, right, which is just, it's ash. Very tiny, powdery material. So an example of a cinder cone volcano would be like this one in Mexico, which is one of the youngest volcanoes on Earth. And again, you can see that lovely cinder cone shape that it has. The last one is the composite volcano or the stratovolcano, and we call that word strata or strato means layers, right? And so the stratovolcano is made of many different alternating layers. So layers of lava flow, so like liquid flowing rock, layers of ash, and then unmelted hard rock as well in there. So just different layers on top of layers. And they have very wide bases, but also very steep sides. And they can erupt from different openings similar to the shield volcano. And they are usually very violent eruptions. So you do not want to be near this volcano when it's going off. And those violent eruptions are due to all of that magma, again, building up in the magma chamber and creating enormous amounts of pressure, right? Similar to what we saw in this simulation here, right? So eventually that lid just bursts off. So that lid of the volcano just bursts off. And some examples of that would be Mount Fuji, which is in Japan. That's the second tallest volcano in Asia. And then Krakatoa, which is a very famous series of islands. There's 4 of them out in Indonesia. And the last time it had a violent eruption, or the most violent eruption, was in the 1800s, and it was 13,000 times the strength of the atomic bomb that was dropped in Hiroshima, Japan. So very, very, very like massive amount of power, like huge explosion. Like no one's gonna survive that. Crazy. So this is kind of like a drawing that they made. Right back then they didn't have cameras to take pictures of Krakatoa, unfortunately. That would have been pretty interesting to see. But some more facts. It caused a 120-foot tsunami, right? So the big wave that carries on over to land. The ash was over 10 feet deep in some spots. So normally you don't get that much ash from volcanoes. 10 feet deep, that'd be like more than any snow we've ever gotten in a blizzard out here in McHenry. That's it's taller than me in ash, right? So you'd be swimming through that. It changed the color of the sunset for 3 years. So that's all that volcanic debris in the air, right? That pyroclastic material, it sits in there, right? That volcanic ash, it gets up in the layers of the atmosphere and it's stuck there. And so that, when it's stuck in the atmosphere and the sun shines through, it's going to change the colors that you see because it's reflecting light. Some light is passing through the ash and it's going to give you a different color sunset. And that lasted for 3 years. Those particles were in the air for 3 years after it erupted. So it's a very long time. Pretty crazy. So I had mentioned before that not all eruptions are super explosive like that. Some of them are, sort of just lava flowing down the sides, a little bit more relaxed. So those would be called effusive. So it builds up only enough pressure to allow the lava to come out of the volcano and flow down the sides, where explosive is just how it sounds, right? A huge amount of pressure building up inside that magma chamber, and eventually it all busts through the surface in a very violent eruption. So those are the two different types. And we're going to pause there. There's a couple more notes that we will go through later, but we're just going to pause there with the different types of volcanoes. So if you have any questions, feel free to email me, but make sure that you've got those notes, the PowerPoint notes slides filled in terms of those fill in the blank notes. That's all. I hope you guys have a great rest of your day, and I'll talk to you soon.